Dummy coding allows categorical variables to be included in multiple linear regression by converting group membership into binary indicators. Because regression requires numeric predictors, each non-reference category is represented by a dummy variable coded 1 if a case belongs to that group and 0 otherwise. One category is omitted and becomes the reference group. The regression intercept then represents the mean of the reference group, and each dummy coefficient represents the expected mean difference between that group and the reference group, holding other predictors constant. In this way, dummy-coded regression directly estimates group mean differences within the general linear model. When a regression model contains only dummy variables representing groups, it is equivalent to ANIVA. For example, with 3 groups, 2 dummy variables are created, leaving one group as the reference. The overall F-test of whether all population regression coefficients for the dummy variables equals 0 is identical to the omnibus ANOVA test of equal means. If there are only 2 groups, a single dummy variable is needed. The slope coefficient equals the difference between group means, and testing it with a t-statistic is numerically identical to the independent samples t-test. The independent samples t-test is equivalent to a one-way ANOVA with 2 groups and can be written as a regression model using a single dummy variable for treatment. The regression coefficient for this dummy variable represents the mean difference between groups, which is exactly what the independent samples t-test tests. The paired samples t-test can also be expressed in regression form by restructuring the data into long format. We include one dummy variable for treatment and additional dummy variables for participant IDs to control for individual differences. The coefficient for the treatment dummy represents the within-person mean difference, matching the paired samples t-test. In this sense, independent t-tests, paired t-tests, and ANOVA are all special cases of the same linear model. They differ mainly in how predictors are coded, but they share a common regression framework.